we're going to solve some more quadratic equations, but we're going to incorporate some other methods besides just factoring. Let's look at our first example. Here we have the quadratic equation, x squared minus 50 is equal to 0. Notice there's no linear term or no variable that just has x to the first power. So what we're going to do to solve this equation is we're going to use what's called finding the solution by using the square root property. To use the square root property, what we have to do is isolate this quadratic term. So that means we're going to add 50 to both sides of this first equation. So x squared is equal to 50. Again, because there is no linear term, what we're doing here is we're isolating that quadratic term by adding 50 to both sides. Once I've done that, I can get x by itself if I take the square root of x squared. So this is called taking the square root of both sides of the equation. Remember, we can do whatever we want to an equation as long as we do it to both sides. So I'm going to go ahead and take the square root of the left-hand side of the equation and do the same thing to the right-hand side. When I do, on the left-hand side, I simply get x, and on the right-hand side, remember, there are two possibilities, a positive and a negative value, so that gives me plus or minus the square root of 50. But now, we are experienced enough with our radicals that we recognize that the square root of 50 is not in simplified form because there is a factor of 50 that's a perfect square. In fact, it's 25. So we're going to change this down here to plus or minus the square root of 25 times 2, or in this case, we know that the square root of 25 is 5. So finally, we conclude that x is equal to plus or minus 5 times the square root of 2. So this solves our first quadratic equation. Again, what we used is called the square root principle or property. All that means is we can take the square root as long as we do it to both sides of that equation. Let's look at our second quadratic equation. Over here we see 2x minus 3, quantity squared, is equal to 12. Now notice where the x is. It's within the parentheses that's being squared. We want to get that x out of the parentheses, and we want to isolate it so we can solve for the value of x that will make our statement true. So again, what we're going to do is incorporate the square root property. We're going to take the square root of both sides of our equation there. When we do, on the left-hand side, you'll see we get just 2x minus 3. On the right-hand side, we get plus or minus, because whenever we take the square root, there's a positive or a negative value that are possible there. The square root of 12, and we know the square root of 12 here can be broken up into the square root of the square root of 4 times the square root of 3. Are you following what I did here? I took the square root of both sides of my equation because I identified the fact that my variable x, which I want to solve for, is within these parentheses being raised to the second power. Taking the square root of both sides allows me to get to this step. Now notice x is no longer trapped inside those parentheses. On the right-hand side, what I did is I recognized that the square root of 12 has a factor that's a perfect square. In this case, that's 4. So I break 12 into 4 times 3. Now let's continue. We have 2x minus 3 is equal to plus or minus 2 root 3. And again, remember our goal is to solve for x. So I'm going to add 3 to both sides. And now what I'm going to do, just to make it look a little nicer, is instead of writing the plus 3 over here, I'm going to write the plus 3 right in front of my term. It doesn't matter where we put it, but if we just like it up front, it looks a little nicer. So we'll put 3 plus or minus 2 root 3. Now again, what I did was just write this 3 in front of the expression on the right-hand side, just because it looks a little nicer this way than to start with this and have the plus 3 off to the right. Now we're almost there. Can you see that all we have to do at this point is to divide both sides of this equation by the number 2. So when I do, I get x equals 3 plus or minus 2 times the square root of 3, that whole expression on the right divided by 2. So this here is the solution to my quadratic equation up here at the top. Now, what did I use in both of these quadratic equations to solve? I used what's called the square root property. There is one other method we're going to look at that helps us to solve quadratic equation. It is called the completing the square method. Now, what does it mean, completing the square method? Well, let's first of all look at our equation. We're going to solve the equation x squared plus 10x is equal to 3. Now again, observing that this is a quadratic equation because we have a variable to the second power. But now it's different from those previous two examples because now we have this linear term x in addition to that quadratic term. So this is going to make it just a bit more difficult to solve. Again, what we're going to use is called the completing the square method. And here's how we do it. The first step is to rewrite the left-hand side of the equation, x squared plus 10x, but we're going to leave a little space, and then we're going to write equals 3 on the right-hand side. So are you seeing what I changed? I didn't change anything, did I? X squared, 10x, space, equals 3. I didn't add or subtract anything. Now what we're going to do is we're going to try to make the left-hand side into what we call a perfect square trinomial. In other words, what we want to do is get a trinomial in the form so that when we factor it, it becomes a binomial squared. Or in other words, it looks something like this, a plus b quantity squared. We want a binomial squared to come out of this trinomial. So we want to make a perfect square trinomial out of the left-hand side. All we have to do here is identify the coefficient of the linear term. In this case, that's 10. Take half of it, 5. Square it, 25. That means we're going to add 25 here because that's going to create my perfect square binomial. Now, since this is an equation, we all know that if I add 25 to the left-hand side, I must add 25 to the right-hand side of my equation. Now what happens here? This factors into x plus 5 quantity squared. Check that factorization on your own. And on the right-hand side, 3 plus 25 is 28. Now we're to the point where we have something squared. So do you feel what the next step is? You're absolutely right. We're going to use the square root property and take the square root of both sides of our equation. When we do, we get x plus 5 on the left-hand side equals, and again, on the right-hand side, we identify 28 as having a factor that's a perfect square. In this case, that's 4 times 7. All right, we know that the square root of 4 is 2, so the right-hand side is really plus or minus 2 root 7. Finally, to solve for x, all we have to do is subtract 5 from both sides of this equation, and we can see that x is equal to negative 5 plus or minus 2 times the square root of 7. These are the two solutions to our quadratic equation. Now let me just go over again the method for completing the square. To complete the square, to create a perfect square trinomial, what we're going to do is take the linear term 10, or whatever it is, just take the linear term, divide by 2, and then square it. Whatever number you get, you're going to add that number to both sides of your equation so that when you factor your trinomial, you'll get a binomial squared. Now this is what might take a little work for you. I would suggest that you run through this procedure probably 1 or 2 times. You'll see that learning this procedure is going to bring you to some very important formulas coming up in the next few sections.